Hi everyone, and welcome to the AWS Nordics Office Hours with me, Gunnar Grosch. I am a developer advocate here at AWS. So this is our weekly show out of the Nordics where I bring on a guest to talk about a specific topic and let you, our guests, or our viewers ask any questions you might have on that topic. So if you have any questions throughout the show, just post them in the chat and we'll do our best to answer those questions. And this week, I'm joined by Pankaj Agrawal. He is a solutions architect based in Oslo. And this week, we're going to talk about simplifying serverless best practices with AWS Lambda Powertools. Welcome to the show, Pankaj.
Hey, Gunnar. Happy to be here. Hope you can hear me all right.
We can. And I hope you can hear us as well. You viewers, please post something in the chat so we know that you're with us. So, Pankaj, tell us the short story about yourself.
Yeah, sure. So my name is Pankaj Agrawal. As Gunnar mentioned, I'm a solutions architect based in Oslo, Norway. I've been with AWS for more than 2 years now. I primarily work with customers across Nordics, helping them obviously leverage AWS in a best possible way. In addition to working with customer, I also spend a lot of my time doing what we call as thought leadership in AWS, which is building a lot of like technical artifacts which can be reused by our customers. And one of the topic that we are discussing today is also something that I worked on as a project. So yeah, very excited to be here today.
Yeah, glad to have you here. So I mentioned the topic, simplifying serverless best practices. So let's take things from the beginning then. Based on that title, why did you build AWS Lambda Powertools?
Yeah, that's actually a good question. Before I actually talk about why we built it, I think it's important to discuss about AWS WellArchitected. I'm sure many of our customers have heard about AWS WellArchitected, but AWS WellArchitected is basically it helps cloud architects to build secure, highly performing, and resilient infrastructure on AWS. You can think of it as a set of best practices that are in form of questionnaires, which provides architects and technical people to basically have a consistent approach for our customers to evaluate their infrastructure and architectures in AWS, right? And AWS WellArchitected has been there for quite some time, but what has interestingly happened is we have actually made it self-service in past few years. So meaning that you can actually go into AWS console and have your own well-architected being executed in a self-service way. And another interesting thing that happened on top of it, as I mentioned, that it's composed of 5 pillars and different questionnaires around best practices around these pillars. But few years ago, we also started to introduce something called lenses, and these are something which are on top of the standard well-architected tooling, but it provides that extended guidance towards, say, industry-specific domain or technological domain, right? And one of the lens that we have here is called well-architected serverless lens as well. And now going back to, again, answering the question on why we actually build it. So if I go today and try to start with a well-architected review myself in my AWS account, I could, as I mentioned, easily go and search for AWS well-architected tool, and I can come here and define a workload that I want to evaluate. And that's what I've done here. It's a sample workload that I created. And you can see here that I've also chosen, because probably my application or my architecture involves serverless workload heavily, I've also chosen to pick like serverless lens as one of the additional guidance around my infrastructure and architecture. And if you go through some of the questions that we ask in this, even the first question that you go through it, it talks about that how you evaluate your serverless application's health, right? And as part of the best practices, we ask that you should have structured logging in place. You should have distributed tracing enabled, and also you should think about capturing business and operational metrics, right? Which is good, and we have been hearing a lot from our customers as to how useful these sort of recommendation and best practices are. So when you are going through this well-architected questionnaires, we also suggest a lot of, say, best practices and how you can achieve these best practices. So if I go further down in this tool, you'll see that we have a bunch of links which actually guides you to implement this. And customers were really finding this helpful. But there was another set of customers which said that, hey, these guidance are really helpful for us. But how can we make sure that these best practices, we are able to have those in place from day one when we are actually starting to, say, build a serverless application in the POC phase, etc.
Yeah, I think it's important to point out that this tool doesn't make any changes. It doesn't build your applications. It is guidance, as you said. It's a way of making sure that you are following these best practices.
Yeah. It's basically a sort of, as I said, consistent approach towards evaluating that how your architecture is doing, and is it following the best practices that has been battle tested based on our working with a lot of customers in the similar domain, right? So what I was coming to here is that the whole idea was basically to bridge that gap from having the best practices, not all the best practices having in place from day one, because obviously it takes time, but at least the core ones that we say, like structured logging, distributed tracing, and operational and business metrics, it should be really easy for our customers to have that in place from day one, right? So that was the whole idea behind why we actually started to think about AWS Lambda Powertools. So yeah, Gunnar, I hope that answered the question around why we actually build Powertools.
It did. Right. So now maybe the best way of actually showing what AWS Lambda Powertools is to actually start using it. So
yeah,
should we jump straight into the demo part and start from the beginning?
Yeah, definitely. I guess we can do that. But before I actually go into the demo and show you the tool in action and what are the features that it provides, I'll just walk through some of the basics around the tool itself and where can you find more information around this tool. So I'll quickly bring up just one slide, and I promise that this is the only slide that you'll see during the session today. But this is AWS Lambda Powertools, right? It today exists as a GA version, both for Python and Java. As part of the demo today and showing some of the functionalities, I'll use Java as the example, but Python version also exists for it today. Having said that, what AWS Lambda Powertools is, it's basically a suite of utilities that makes you to adopt the serverless best practices in a quick and easy way, right? And what it consists of is coming back to the serverless lens and the question that I was showing in earlier. We talk about having structured logging. We talk about having a good way of capturing metrics and having distributed tracing. So targeting those three themes, there are three core utilities, as we call it, which are logger, metrics, and tracer. And what's special about the core utilities is that these utilities you will find across all the available runtimes for Powertools. So today we are talking about Python and Java. In future, if there are more runtimes coming in, these core utilities will always be present in all the runtimes and probably will have similar user experience and same functionalities across all the runtimes, because these are the core utilities. But not just these utilities, it also consists of utilities, as we call it. And these are again a set of helpful utilities which are again driven by the community feedback around some of the things for which our customers had to write a lot of, say, boilerplate code to implement things, and those are implemented as part of utilities as well within Powertools as the project, right?
And that also means that they can differ based on the language, because there are different needs for different languages or runtimes.
Exactly. Yeah, that's correct. So some of the utilities, which like not the core utilities, but the sub utilities that you see here, might also be common across runtimes. But then again, it's heavily driven by the community feedback. So if Java community is asking for a specific utility which exists in Python as well, we'll try to incorporate that as well. But again, important thing to mention here is that it's an open source project, which means it's open for community to contribute as well as provide feedback. And we very much encourage that do evaluate this as a project, and if you have any suggestions for us, or if you want to contribute, we are more than happy to guide you there as well. So coming back into the Powertools project itself, currently what you're seeing is the documentation of AWS Lambda Powertools Java. And the Python one also exists on the same path, but you just need to change it to Python, and then you will see the Python documentation, right? So going back, these are the core utilities, and all of these I'll walk through as part of demo as well. So I won't go into the details within the documentation. And then there are a bunch of utilities, and I guess we can cover some of those if time permits as part of the demo as well. All of this is also open source on GitHub, as I mentioned. So entire source code is there on GitHub, both for Python and Java. So moving on, I guess as I promised that I won't show more slides and do more of hands-on. So coming back to the demo, and I hope the demo works today, but let's see how it goes. So as Gunnar mentioned, if you have any questions during the demo or whatever I'm showing, feel free to drop that in the chat, and then we can see, we can cover that during the demo or post-demo as well. So as I mentioned, one of the tenets, as we call it, has been to improve or bridge that gap of getting customers started to have those best practices in place from day one, right? So in addition to building the Powertools as a project itself, which solves most of it, like the core utilities, we also build a SAM init template, right? So if you are familiar with AWS SAM, it's called AWS Serverless Application Model. It's basically a higher level abstraction on top of AWS CloudFormation, which makes it easier for you to implement serverless applications, right? It provides higher level abstraction. So one of the feature in SAM is that it provides you this quick start templates around certain patterns, and you can in fact define your own custom template as well, and then it will create a SAM application, as we call it, for you, set up and ready to be deployed into AWS account. So in order to, again, get customers started really quickly, we have this cookie cutter project, which is again a custom template, which basically sets up this entire SAM application with Powertools configured by default, right? So you don't have to spend time to basically set up the Powertools as a dependency. But I mean, it might not be relevant for all the use cases, because many times customers already have a function which is working in and operating in production, but then you can leverage the documentation that I was showing earlier to basically include those dependencies. But today I'll use this as an example, and I'm showing the Java version of it, but Python also has similar support. And most of the core utilities that I'll talk about, it will obviously show Java as an example. But since that is a core utility, you can expect that also exist in Python as well, like the feature set. So since we are in Office Hours, I guess we'll create a demo project called Office Hours. I'll pick Java 11 as my language runtime. I'll use Maven as a dependency manager. And that's it. Now I have a SAM application created for me, which is ready to be deployed, pre-configured with AWS Lambda Powertools. Before I actually go into my IDE and show you what we have got out of this init template, in order to save time, I'll quickly build this project and also deploy it to my AWS account so that it's there by the time I'm walking you guys through the project itself.
And so perhaps also explain what a SAM template really means if you choose or create a SAM template.
Yeah, I can do that quickly. Probably it will be easier if I show that in my IDE, how it relates with AWS CloudFormation. So let me just quickly just deploy this stack. So when I'm doing SAM deploy G, basically I'm deploying this application into my AWS account. My SAM CLI is pre-configured with my AWS credentials. So that's why I'm not putting in any credentials right now. But if you are doing it for the first time, you'll have to configure that, right? So I'll just put a stack name, which will be used when it's going to be deployed as a CloudFormation. I'll use US East 1 as the region, and then a bunch of formations that it needs to create. And I just need to acknowledge OK for all. And now it's going to deploy things, right? So I'll let that deploy, and then I'll quickly open up the project now and show you what we have got by just running that SAM init command and what exists. So let me just quickly set this up. Trust the project. So yeah, before I actually now go into the Power Tools and some of the APIs that we have configured, this is what I was referring to as SAM templates, right? So this, if you have used AWS CloudFormation before, it will look very familiar to that. But again, it provides like a higher level abstraction resources. So you can see for creating a Lambda function, you have a different type of resource that you use, but then it takes away a lot of heavy lifting when it comes to creating your serverless resources using AWS CloudFormation. So that's SAM template 101 for you. But I mean, it has a lot of other higher level abstraction as well to get you up and running very quickly with your serverless workload. One important thing to mention here is that it's also compatible with CloudFormation. So say if there is a resource which works together with your serverless application, which is only present in CloudFormation, you can use those directly in the SAM template as well.
And this specific template contains one AWS Lambda function, and it will also set up an API. Is that correct?
Yeah. So in this example, what you're seeing is basically just this part of the code will basically deploy a Lambda function and then hook it together with an API gateway REST API and make the path available on /hello, right? So just with this line of code, this entire thing is created with the least privilege permissions that are required between these resources to interact, etc. So yeah, then now moving on to, I guess, the actual tool that we are discussing today. So as I said that when I did SAM init, it created a Lambda function for me, which is integrated with API gateway. And at the same time, it also configured Lambda Powertools with the core utilities in place, right? And this is Lambda Powertools for you, incorporating all the core best practices that I was showing earlier in the serverless lens first questionnaire, logging, tracing, and metrics. It provides a higher level abstraction. So it's not that you cannot do those, you cannot implement those best practices without using Power Tools. It's just that it takes away that heavy lifting that customers had to do in addition to all the other things that they are doing, like serverless, they are building application and also taking care of writing business logic. Many times we see that customers sort of delay incorporating these best practices until the POC is ready and all. And then while they are going towards production, then they start to suddenly worry about, oh, do I have proper monitoring? Do I have proper observability around this, right? And this really bridges that gap wherein you use these three annotations and configure few things that are needed, and then you're good to go with at least the basics of it. Obviously, you'll have to customize this a bit in order to make sure that it works the way that works best for your organization and your development team. But it generally gives a good head start when it comes to adopting those best practices. So yeah, I guess I'll go through the utilities one by one, even though we have all the things configured by default. So I'll just quickly remove these and talk about logging first, right? So as I mentioned that in our best practices, we prescribe that we should aim for structured logging. And structured logging is basically serializing your log in a JSON format in a standard set of output so that you can easily reason about it by using any popular log analysis tool. Like for AWS, we have AWS CloudWatch Log Insights, and I'll show that in demo as to how helpful it makes when you have the structured logging to query things. And you have other open source partner tooling as well, like Kibana and all those tools, right, which can leverage these structured logging to help you figure out what's going on in your system. So with this, if you have this logging annotation, even without having anything else, you'll basically start to get structured logs out of your Lambda function. And not just structured logs, you'll start to get a lot more context information from your function, right? So what this utility will do is actually it will look into the context object of your function, and it will inject a lot more information in your logs, say function name, function ARN, function memory size, cold start, and all those information will be injected for you. So you don't have to write anything explicitly.
Explain what the context object is.
Good question. Probably I should have done that. So if you are writing a Lambda function, right, you basically expect two things as an input when your function is invoked. One is the payload itself, like the event with which the function has been invoked, and the other thing is context information of the function itself, right? And as I mentioned, some of the metadata around function, say function name, memory size, all those information are present inside this context object, which is made available by Lambda runtime when it's invoked, right? So that's context object for you. So this utility makes care or takes care of inspecting this context object and make sure it injects helpful information, which we have seen from our learning that customers need when they're troubleshooting something in production, right?
Right.
So the other interesting bit is this is probably a bit more relevant for our customers who are using Java to write their Lambda functions. So the utility is based on Apache Log4j, which is one of the most popular logging framework in Java world. What that means is basically if, again, you are using Apache Log4j for logging inside your Lambda function, you practically don't have to change anything except for using this annotation, and then it will hook onto the Lambda function or the Apache Log4j framework and start to inject all those structured logging with the additional context information, right? To demo that in action, now as you can see that the stack has been deployed, it has created a function for me, and then it has also displayed the API gateway URL, which will be talking to this function. So I can probably try to invoke this. And if you will look at the function itself, it's not doing much because the idea is to get the tooling in place and not really write a business logic for the customers, right? Customers know very well what business logic they want. So this is very simple function just to demonstrate how you can do things. So it's basically calling a third-party API to find your IP, right? That's what it's doing. Nothing more magical than that. So if I invoke this, it is basically generating those structured logging under the hoods. And to actually see that in action, you could go to Service Lens map. Service Lens is one of the service under a CloudWatch umbrella. Which basically it's an attempt to bring the entire observability into one place, right? So it will be talking to different services, say CloudWatch Metrics, CloudWatch Log Insights, AWS X-Ray, and have that visibility in one place so that customers don't have to navigate into different services to figure that information out. And that becomes even more important when you are like troubleshooting something in production, right? So that's Service Lens for you. So this is the function trace that has been generated. So you can see it's being invoked by client. Then Lambda context is basically invoking the Lambda function itself. So if I have to look into the logs part, what logging has been done, if I go here quickly and just try to query my logs, and this is Lambda Insight, Log Insight for you. CloudWatch Log Insights basically provide you this nice handy feature of allowing you to query your logs in much like a SQL format, wherein you just query things on certain fields, and then you can get insights on those fields that you want, right? So if I am to query this, hopefully this should show something, but as always during demo, it somehow doesn't work.
But this is just to show that we're live, so people know that we are actually live.
Yeah, that's true. But let's see if I could figure out why it didn't show it up. Probably I was too back far in time. So if I go here and try to run this query again, no data found, typical. But the whole idea is basically that you'll get the structured logging and then you can easily query on those logs, right? Let me try once again if I am able to. So if I go to my Lambda function, hopefully something exists there. And this is my function. If I go to monitor and try to view the logs, it should show something here. At least it shows here. And you can see a lot of logging. What I wanted to show was to make it easier for you to reason what we are seeing here. But anyways, what you could see here is that this is the log generated out of @rate logging annotation. And you can see that it has message, obviously one of the things that we log, but at the same time, it has a lot more context, which you can use in Log Insight that I was trying to show you before, and basically say query on, hey, show me all the function logs that have cold start equal to false. And then you can try to reason about what you are trying to figure things, right? So that's one thing. The other thing, obviously, we have a lot of add-on to this as well. So I'm pretty sure if you have been writing Lambda function, and especially in your development and staging area, the first line that you write in your Lambda function is sys out the event itself. So you want to see what kind of event you are receiving, right? So we wanted to make that very simple for customers. So if you are using Powertools, you could basically say log event equal to true, and then it will start to log event that has been received serialized as a JSON. And it's very handy for customers when they are initially developing using this to have that information there by default and not having to spend any effort to figure that information out. So this is again a sample log where we have logged the event as well. We have been hearing from the community.
I think we lost Pankaj. Let's see if he comes back. All right, in the meantime, this is the AWS Nordics Office Hours with me, Gunnar Grosch, and I'm joined today by Pankaj Agrawal to talk about serverless best practices using AWS Lambda Powertools. And let's see if Pankaj is just having a quick connection issue, and let's see if he comes back. All right, I'm getting messages. He is on his way back, so don't worry. In the meantime, I can just have a look at the chat to see if there are any questions. There are some questions. Do you prefer Java or Python runtime? And I suppose this was a question for Pankaj. And I know that he prefers Java as runtime, so that's why he's demoing Java as well. But as he mentioned early on, when it comes to AWS Lambda Powertools, the core utilities are the same for Java and Python. So it doesn't really matter there. But for the additional utilities, there are differences based on which runtime you're using. And the other part of the question is around cold starts. And I suppose this is for the runtime only, not in regards to Powertools. And cold starts, if you aren't familiar with it, cold start is the short initialization time it takes for an AWS Lambda function the first time you run that AWS Lambda function, when it starts for the first time. And there is, of course, a short period of time before that function is able to respond or respond to that event. And this is something that has been improved a lot throughout the past couple of years. And so cold start isn't really an issue for many customers today, but there is slight differences between the different runtimes. What some customers do as well, if they are in a situation where cold starts, well, the time it takes to do that first invocation of a Lambda function is very important, is to use reserved concurrency, or being able to have Lambda functions that are hot so that you don't get that cold start. So let's continue on. Suggestion to his error that he wasn't using the correct log group. Perhaps that might have been the case, or it was just a matter of it being so close in time from the invocation to when he actually started querying them. Tell us a serverless joke. I don't have a serverless joke, but please feel free to post them in the chat. And I guess this is the most common question when it comes to AWS Lambda Powertools. Any plans to do a JavaScript version? And I know Pankaj will be able to answer that better when he is back online. But there is a roadmap. Let me see if I can get that up for future runtime versions. Let me try to open that quickly. So they have a public roadmap for AWS Lambda Powertools. Go, just starting my screen share as well. Here we go. So this is the public roadmap for the AWS Lambda Powertools project. And this is available on GitHub under AWS Labs. I can post the link in the chat as well. There we go. So they are working on additional support, runtime support, and they are working on TypeScript support at the moment and .NET support at the moment. So those are, I would say, based on this, the languages or runtimes that are closest in time. And would you look at that? We have a guest on again. Welcome back, Pankaj.
Can you ever imagine?
Well, if there's ever a time where your computer would crash, it is during a live stream. So
exactly.
Oh well, I've been.
This is very embarrassing, but guess we cannot control technology.
Things happen. Everything breaks all the time. So
yeah.
I've been trying to answer some of the questions in the chat and was just opening up the Powertools roadmap to talk a bit about future runtime support.
Yeah.
And I mentioned TypeScript and .NET, but perhaps you can elaborate on it.
Yeah, that's true. I actually had that later during my session to talk about that as well. But let me try sharing my screen again. Hopefully, it should not crash again.
I said that it's probably the most common question around Powertools support for other runtimes. So all right.
if you will actually see that we have, in fact, both of them, the .NET and TypeScript support on our roadmap. And I knew that we are going to get this question, so I especially reached out to the team who is actually working on it and to sort of gauge when do we expect this to happen. So we are expecting a public beta for both of them by end of this year. So hopefully that should shape up well, and you should have a public beta for both of them around the end of this year.
That's awesome. Right. So, well, let's get back to the demo then. I think where were we? You showed us. You showed us the logging and that you were able to get the event to the logs easily.
Yeah, that's where we were. I just need to get my IDE up and running so that I can start talking again.
Yeah. So maybe while that's loading, we can have a look at this. Garuna asks, what's the easiest way to search across the Lambda logs, since there can be multiple Lambdas that write to the same log stream? Are you with us, Pankaj?
Yeah, I can hear you. It was again a hiccup.
All right. So the question was the easiest way to search across. I'm not sure if the question is how to search across different log streams.
So I guess what the question might be is what I was showing is the log insight, right? So if you are to basically query your logs inside a log stream, and basically you do that on a log group, right? So you could select a log group that you have created for your function, and basically you can then query inside that log group. It doesn't prevent you to have like only one log group, so you could have multiple log groups as well selected and query on that. So I guess that's what the question was.
Yeah, I think that answers the question.
Yeah.
All right. So if you just joined us, as Pankaj, he just joined us back. This is the AWS Nordics Office Hours, and my guest Pankaj is talking about AWS Lambda Powertools and how that helps us to simplify serverless best practices. And if you have questions, just post them in the chat, and let's get back to demoing, Pankaj.
Yeah, only if my IDE will start, because everything will go wrong today in this 1 hour. But let's see. It's at least showing that it's starting.
All right. So, wait.
Okay. Looks like it's back up. So what I was about to show next is obviously we are hearing from customers around feedback and what they would like to have. So one of the feedback, again, that we incorporated as part of this Powertools project was customer said that this log event is great, and probably we don't only want to use that for our testing and staging area. We would probably want that to be there in other use cases as well. But what we don't want is sometimes our payload has sensitive information and we don't want that to be logged, right? So what we, based on that community feedback, what we provided was you could, again, now my IDE is indexing a lot because it crashed, so it takes time to index everything. But what you can do basically is you could go inside logging utils, which is again a class that we provide, and you could override your object mapper. So for people who are familiar with Java world, you have this object mapper which you use for serializing your object, and you can use this object mapper to define your configuration, right? So if you don't want certain things to get logged, you basically provide utility with your serializer, how you want the payload to be serialized, and then we use that serializer to serialize the log. So that's another neat feature which I thought I'll mention. I guess we have already wasted some time because of all the things that happened. I'll quickly move on to tracing part. The tracing is another like a feature which is provided as an annotation, and what it lets you do is basically have the distributed tracing within your function. And not only that, you can basically have tracing inside your function, and I'll get to the point where what does that mean. So when you are doing tracing, you are basically tracking your end-to-end requests, right? So if your request is coming in, say via API gateway, then it reaches Lambda function, then it probably talks to few other services, say S3 and DynamoDB or any other services, right? You want that track of what is happening while this request is being served. So how much time does it take to invoke the function? How much time does it take to call the DynamoDB, etc.? But while that is a good information to have, oftentimes we recommend customers to actually instrument their function itself. And what that means is basically instrument the critical parts of your business logic. So, right, suppose you are doing something which is much more important than getting page contents, say processing an order, right? And you want to measure what's happening when that function is called. Before, customer, if they wanted to do this kind of instrumentation within their code, they had to write a lot of boilerplate code in order to have that information in place. With tracing annotation, what you do is basically you go and annotate your function with @tracing. And now we are now instrumented with tracing this function. So your function information is being tracked here. And I'll show how does that look in action when you go into the AWS X-ray console. Other neat feature that this provide is you can define capture mode. And what this capture mode means is you can instruct the annotation to capture the metadata of the function's return type, right? So suppose you are debugging something and you actually want to see that when this request happened, what did my function return, right? So you can configure it to capture that information as metadata. If there is an exception, you can also configure it to capture the error as well, and that will be available in the trace as a metadata. So that's one thing. Other thing that you can also do is if you go to tracing utils, you can capture annotations on your segments or subsegments as we call it. And what this annotation lets you do is to quickly search your traces. So in a simple application, you're not just working on with one request, there are millions of requests, and you suddenly want to say identify a problem with, say, order number X. So you can practically capture your order number as annotation, and that will be made available inside your X-ray console to search on it, right? So what that means is if I go to X-ray console, not C-ray, but X-ray, you'll see a very similar looking graph that I showed a few minutes ago in the Service Lens console, because Service Lens is trying to get all that information in one place. But if I go here and go to view the traces, you could see that I have a lot of invocation that has happened. But then again, I need to drill down and find what happened when this request came, right? And you can see here that it's not just having the function level information now, it's actually having much more deep down level information around this method call itself, right? And if I go inside the metadata, you could see that it has even captured the response from that method when this request came in. And all this happened because when I was showing you this, the capturing of response is the default behavior of the annotation. So by default, we do that as a metadata. But then again, if that is something which you don't want by default, you can disable it as well. So we provide all those hooks to do that. So that's about tracing, I guess. I can quickly jump onto metrics part of it, which is again starting with metrics annotation. And as I mentioned, that one of the best practices that we recommend our customers to do is to collect metrics at all levels, meaning that as much as the operational metrics are important, business metrics are equally important, right? And we wanted to make that experience of capturing metrics, both operational and business, seamless and easier for customers, right? And this is what you do get with metrics annotation. So before, when customers were capturing metrics, they used to call a real-time or synchronous API call to CloudWatch metrics to capture their business or operational metrics, right? And it has two disadvantages. One is that you're making a synchronous call, so that sort of incurs performance hit for your end customers, whereas that is not relevant for them, because you are capturing something for your own troubleshooting or information, and the customers should not suffer in terms of response time because it's a synchronous call. And the other aspect is that, as you know, Lambda function, you are priced based on the amount of time that your function executes, right? So it has the cost aspect attached to it as well, wherein the synchronous call is adding up to the execution time of your function. So what we do differently in metrics is that we are using a thing called AWS embedded metric format. And this is something which was launched, I think, reInvent 2019 or somewhere around that. And the basic concept of this is basically it lets you log your metrics in a specific format, and then CloudWatch takes care of converting those logs to a metric, right? And what is the advantage is that you are no longer doing a put metric synchronous API call. You are just logging it like normally on your STD out, and then CloudWatch takes care of that heavy lifting of putting that as a metric. And that's the thing that we use here. But then again, we provide a higher level abstraction so that it's really easy for you to just start capturing the metrics. And how you do that is once you annotate with @metrics, you get access to this object called metric logger. And then basically you just start capturing metric. And then it will take care of logging that in the format that is needed by CloudWatch EMF format. And then it is available as a metric. Some neat handy utilities on it, like we often heard that, hey, we want to capture cold start metric. So you could just toggle this flag to true, and then you will have cold start metric captured for you by default, right? So if I show that in example, again, going back to how this looks in the real life, you could see that I have this office hours namespace being created for me, and then there is a cold start metric that has been also captured as part of the invocation that we did just by writing this part. And if I was having, say, my business metric that I want to capture, I could do that as well. And it will automatically get captured as part of it. So that's majorly about these three core utilities that I wanted to touch upon. Yeah.
Cool. So there's a question in the chat. Where are these metrics stored? And you just show that they are stored in CloudWatch.
Yeah.
And this, yeah, go ahead.
So I was just trying to even show that how does it looks when it gets logged. Probably it's not very easy right now to find it because we have had too many calls already. But basically, it's a format that I was showing here. That's where you will see that in the CloudWatch log under the same log group where your function is logging.
Right. And are these accessible from QuickSight, for instance?
I guess there are integrations with QuickSight and S3. So that is one of the way that you could do that to have that being visualized via QuickSight. So that's a possibility, sure.
Cool. And the other question we had was, are these annotations also available in the Chalice framework?
That's a good question, and I think I missed that part, which I should have covered. But it's a good thing that there is a question, and I can then talk about it. So when I was showing you this documentation, I sort of walked through this, but one thing that I didn't touch upon is some of our tenants, right? So currently, we optimize for AWS Lambda functions only. So if it works on Chalice framework, good, but we don't officially support it. So currently, whatever development we do is around optimizations for the Lambda functions only. But
So
I remember, but I cannot be sure because I am like a core contributor for Java. But I remember that Chalice framework supports this, even though it's not officially supported, but it works with Chalice framework as far as I remember.
and Chalice is Python, right?
Yeah.
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 Right. So give it a try, but
Yeah. We
perhaps
don't
not.
officially support it.
No.
Mm.
Right. So those were the three core utilities then: logging, tracing, and metrics.
Yeah.
So let's look then at some of the other utilities that are available. Probably staying with Java, right?
Yeah, I'll try to stay with Java. So as I said, that the documentation exists for both Java and Python just by switching the runtime on the path, and you should lead to Python documentation as well. But these are some of the utilities apart from the core utilities that are supported here. I think some of the most popular ones are parameters, and this utility basically provides you a way of fetching parameters from, say, system manager or secret manager to quickly get those parameters, as well as cache it, right? So you can have like cache this for 5 seconds and then it will do that for you. It also provides ability for you to write your own custom provider. So suppose you are storing parameters in DynamoDB, you could easily extend this utility to have support for DynamoDB as well. So that's one of the utility. For example, other popular one I think is the SQS batch processing, and I could quickly even show a sneak peek into some upcoming feature that is planned for this utility. Only that I'm scared of not making my system to crash again, but I'll anyways try. So what we have been working, and this is pretty new. There is an example repo. This is on AWS Samples. The idea of this repo is to provide customers with like a working application that demos some utility, right? It's a pretty new repo. So it has only one example for Java right now called SQS batch processing. And it basically demos a full version of the application. What SQS batch processing does for customers is if you are, say, processing batch of messages, right? So if your batch has, say, 5 messages whenever it's invoked, um, what customers struggled with in terms of handling those messages is when a batch arrives and suppose one of the message fails, right? And if they don't handle the message carefully, that exception, then the entire batch goes back to the queue, and then the entire batch gets retried, even though you have, say, processed 4 of those messages successfully. So this utility is aimed at easing that experience for the customer. And I'll quickly try to show, also considering the time that we have at hand. So what it provides, I'll remove the sneak peek of upcoming feature. But what you can do is you start with SQS batch annotation, and then you provide a handler or a processor, as we call it. And this processor basically asks you to implement a method which will process a message, meaning that if you have this function which is annotated with this part of the code, then the utility will take care of calling this process method for each of the message within a SQS event, right? So suppose if your function is invoked with 5 messages within an event, then this process method will be invoked by the utility 5 times, right? And what it does for you in addition is, suppose while processing, you ended up processing 4 of them successfully, but 1 of them failed. It will automatically take care of deleting those 4 successfully processed message from the SQS queue. So the only failed one gets pushed back to the main queue, and it will be the only one that gets retried. So it saves a lot of, again, boilerplate code that customers had to write in order to achieve this correctly. But then again, as I said, that this is an open source project, and we are hearing from the community what else they would like to have. So we got this interesting feature request wherein one of the community members said that, hey, this is good, but what if when I'm processing a message, I know that a message is, say, failing a business exception or a validation exception, right? It is not in a proper format that it can be ever processed, right? What's the point of retrying it, say, 10 times until it's finally moved to a dead letter queue or something like that? So they wanted an ability to make this experience better, and this is what I'm showing you is not currently available in any release. It will soon be released. What you can do is you can now define something called non-retriable exceptions. So what you can say that, okay, if during the processing you encounter a illegal argument exception for a message, then treat that as a permanent failure and just move that to a dead letter queue. Or you can even configure it to totally ignore and say that delete the message itself, right? So it provides a handy way wherein, say, a message arrived and you know that it's failing a business, except it's failing a business validation and it will never succeed. You can easily move that to a DLQ just by saying that this exception is treated as a permanent failure, and then the utility will make sure it fetch the DLQ configuration on your main queue, and then it will automatically move that to the dead letter queue. So that's again one of the example of how utilities function. So utilities are not targeting those core aspects, but these are more community driven to allow customers to, or prevent customers from writing a lot of boilerplate codes.
Yeah. No, very cool. And as you mentioned, this was something that was based on feedback from the community as well.
Exactly.
So if people have ideas, if they have things they want to propose, GitHub and the roadmap, is that the way to go?
Yeah. So that's what I was coming into, is that you can look at this roadmap. You can open issues if you have an interesting idea that probably you want to contribute and also influence the project. Feel free to do so. I actually plan to demo some real life application, or more like full-fledged application to look at, which is configured with Power Tools as well. But in interest of time, I won't be able to do that. But this is one example. It's again open source on AWS Samples. It's integrated or using Power Tools just to demo things as well. But it's not just limited to Power Tools, right? So actually, I have this running as well. So the attempt of this project is basically to walk you through how to set up a CI/CD pipeline in a good way, using, say, CDK pipeline or different ways of setting pipeline. But then again, it's also using Power Tools. So if you want to like take inspiration from a real life project, which is much more complex, then you can have look at these open source project as well. There is another one for Python, I guess called e-commerce platform. Again, if you want to look into the Python version of how to use Power Tools, this project also uses that. So that's also something which I thought I'll quickly mention.
Yeah, I'm pasting links in the chat as quickly as I can here. So just open them all in different tabs and have a look at them after the sessions. And with that, Pankaj, I think it's time to wrap it up. We are approaching top of the hour, but we were able to cover quite a lot, even though you were absent for a couple of minutes.
And I am really sorry, but I guess we cannot do much.
No, but things happen.
Complaining to IT again.
Yeah, no worries. All right, so thank you very much for joining us today, and thanks for having a look at AWS Lambda Powertools. And I hope people enjoyed it and that they have a look at it and hopefully start using it to adhere to best practices.
Yeah. And one of the fun fact that I didn't mention, again, I think Power Tools for Python is soon crossing 3 million downloads since the time it went GA. And for Java, I think we went GA in November 2020. And we saw like 30,000 download last month alone. So it's increasing. So I would highly recommend to check out the project and influence it.
And that's a great way to end the show on. Thank you again, Pankaj. Thanks everyone for watching. I'm Gunnar Grosch. See you again next week. Bye-bye.
Bye-bye.